Good morning, everybody. We got a much different video today. As you can see, we're going to be talking about where does the quadratic formula come from. This is a thing as you guys have started to grow up and you've started to become young adults and you've started to honestly just become smarter young individuals. You're starting to realize that, how come I just have to learn this quadratic formula? It's absolutely the most, ridiculous thing I've ever seen before. Who came up with this? It looks like spaghetti soup sometimes, alphabet soup. And just what on earth is going on here? And so you might ask yourself, who made up this weird formula? Where does it come from? I mean, what's actually really cool is that at this point in the curriculum, you have all the tools that you need in order to find it yourself. And so what we're going to do today is we're going to basically walk through the process that a very smart mathematician did years ago in order to come up with the quadratic formula. So the problem of the quadratic formula is basically, how can we solve the problem of a quadratic without really doing anything fancy, by just plugging in the numbers a, b, and c? Okay, so if we think about the quadratic formula, we've got ax squared plus bx plus c equals 0. And now it's time for us to go ahead and start doing the quadratic formula, right? We get a, b, c, we plug it in. But let's pretend we don't know the quadratic formula, okay? Well, if we try to solve this question without any numbers at all, okay, we're going to leave it as a, we're going to leave it as b, we're going to leave it as c. It's pretty much impossible to try to factor a question when you don't know the numbers, because you don't know what the factors of a times c would be. So those that multiply to make a times c would add together to make b, because you don't know what any of those numbers are. But what we can do is we can start the process of completing the square. Okay, so that's our goal here. We're going to complete the square, and we're going to do complete the square where we don't know any of these three numbers, a, b, c. We're just going to leave them as a and b and c. So here's what we're going to do. We're going to have to move the c to the other side. We're going to have ax squared plus bx equals negative c. We're going to use this because we want to add in the perfect number here. And when we add in the perfect number here, it's going to complete this square on this side. Now on the left-hand side, we have this a. And if you remember when we did our complete the square lesson, we talked about how you can't really have that a there. It's going to mess you up because you can't have two binomials that multiply together. If you just have this a, it's gonna really trick things up. So what we need to do is GCF out that a. Okay, and so when we do that, we're gonna take out the a, and left over on the inside we have ax squared, but we lost the a, so it will just be x squared. And this is probably the hardest part of the whole thing to understand. Okay, we have bx and we need to take away an a. Okay, and the way we're going to write that is we're going to write it as b over a times x. Okay, that's how it works. Okay, we basically divided an a away when there wasn't one, so we just put divided by a. If you want proof that this works, we can do a little check really fast. That would be ax squared, and this would be abx over a. The a's would cancel out, and we would have bx, just like we started with. So this does work, I promise. It's definitely like the biggest leap of faith you have to take when you go through this little proof that we're doing here. And so now again, we're looking for what is the perfect number to add in here that would complete this perfect square. Well, we know that if we have maybe something like this, that we need to add in the number 9, because that would be half of 6 squared. And that is what number we would need there, okay? So what we need to do is cut this middle number in half and then square it. So if we look over here, cutting this in half, yet again, is a bit of an interesting thing that we need to do, right? To cut this in half, I guess let me write it like this. To cut this in half, that would be like b over ax times 1/2, right? That would cut it in half. And when you multiply fractions, you multiply across the top and the bottom. So it would be b on top and 2a on the bottom. And so basically, the best way to write this is like this. Okay, we cut it in half. We divided it by 2. The 2 goes down there with the a. So this is half of the middle term. So that's good. Now we need to square that. Okay, and so we're going to have to go ahead and take b over 2a, and we're going to have to square it. Now this x is not the number that we're actually cutting in half, so we don't need to hold on to that x. Once we square this, it's going to look like this. B squared over 4a squared. So this number right here is the 9, right? This is half of the middle number that has been squared. It's a strange looking thing, but that's it, okay? That's what we need. And so we need plus half of the middle number squared. And then we need to make sure that we're equal on the other side as well, okay? We need to make sure that we add the same amount to both sides. But we have one big difference here, okay? We have this a. And if you remember, if you've been following all of the lessons that I've done, we did a question where we needed to add 25 here, but there was a 2 out front, and so that's actually 2 times 25. So we had to add 50, because even though 25 is the number it looked like, it was actually 25 times 2. So we've got to do the same thing. Let me get rid of this orange stuff. We need to multiply this times a. And luckily, that's pretty easy to do, right? What we do is we put an a on top. And when we put this a on top, now we have an a on top and an a on bottom. And these are actually going to cancel out. We're going to lose the a, and we're going to lose one of the a's. So it'll just become an a on the denominator. So let me undo that. There we go. And so this is how it'll look. Okay, again, it's a little weird. Over here, it's b squared over 4a squared. Over here, it's b squared over 4a because we lost one of the bottom a's because of this a. Okay, now, as much as it might seem like we're still a million miles away from the answer, we're actually almost done, okay? Because what we've just done is completed the square. Our square is complete. What we have now is in the form that we like, okay? We have this type of thing going on here. We've completed the square, and so now we just need to put our perfect little pair that goes in there. It would be x plus half of the middle number. So that would be this part here, half of the middle number, b over 2a. So now we're feeling pretty good, okay? We've actually completed the square. Normally when we get this far, we're about 10 seconds away from the answer. But as you can see, this is still quite a jumbled mess, okay? So what we need to do is to start really working with this and making it nicer, okay? And one of the easiest places to start is up here. Let's go ahead and try to make this all one number instead of it being 2 numbers. So in order to do that, we need common denominators. We need to multiply this by 4a in the denominator. And if we multiply in the denominator, we have to multiply in the numerator as well. So I'm going to put a 4. Handwriting is not great. I'm going to put a 4 and an a up here in the numerator. And so to rewrite that, that would be all of this stuff. Getting very close here. Now we have common denominators, 4a. But on top, we have negative c times 4 times a plus b squared. So if I write the b squared first, that's a positive b squared, and a negative 4ac. A lot of times this is the first moment that we kind of get that little aha moment. Oh, wow, that's the discriminant. This is starting to look like the quadratic formula, okay? And it's going to happen really fast, right? Time to divide by a and to divide by a. That's going to make these two a's into an a squared. Dividing fractions is kind of weird. We're going to kind of multiply by 1 over a. And so these two a's are going to combine to make 1 over a, or a squared on the bottom. So we're going to have x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. We're now going to need to square root both sides. We square root both sides. We need to make sure that we have a plus or minus here. On top, we know the square root of b squared minus 4ac, but on bottom, we're actually able to square root both of these things. 4 is a perfect square. A squared is a perfect square. And so, let me keep making myself some room. Working with fractions is taking up a lot of my room here. And so now we've got only x plus b over 2a is equal to, we've got that plus or minus square root b squared minus 4ac. But on the bottom, we could square root this stuff. It's not in the square root anymore. 4 was square rooted and it became 2. A squared was square rooted and it became a. And now you've probably either freaked out or maybe just said, oh, wow, cool. We can go ahead and subtract this to the other side, plus or minus the square root of b squared minus 4ac over 2a. And now we have two fractions. They already have common denominators. And so adding these things together should be a piece of cake. Okay, we're going to add those two denominators together. We're going to have x is equal to one fraction with 2a on the bottom, negative b plus minus square root b squared minus 4ac. And that is the quadratic formula. Okay, so that's where it came from. The idea of the quadratic formula is that we know that quadratics are going to start out over here. Okay, we know that quadratics are going to start out in standard form. And if we start with a, b, c, and we put them here, and then we do all of this process, it can be a mess. Okay, but luckily, the quadratic formula is a way for us to skip all of this stuff. And to even skip this, obviously we need to be given a, b, and c, and we can just put our numbers straight here where x is already solved for, okay? So this is a great way of us to start at the very end of a question. Obviously, the quadratic formula looks like it would be a terribly hard formula to do, but in actuality, it's saving you from all of this, right? We don't have to do any of this. We're able to skip straight to the end. That's where the quadratic formula comes from. I think it's pretty cool because in Algebra 2, you've learned everything that you need to know in order to be able to figure this out. Now, obviously, you don't have a lot of experience working with multivariable proofs. You know, it's really tricky to keep your algebra straight. Some of these fractions, you know, take a pretty comfortable understandings of how fraction work. But at the same time, you guys are such smart young students. I'm sure you guys can handle this. That's it. A little bit of a different video. Hope you enjoyed it. Maybe hopefully you got a little bit of a nice open eye as far as where this stuff all comes from. And have a great day.